Now we have the question, show that the plane 2x plus 3y minus 4z equals to 3 is parallel to the plane 10x plus 15y minus 20z equals to 12 and perpendicular to the plane 3x plus 2y plus 3z equals to 5. So that the plane 2x plus 3y minus 4z equals to 3 is parallel to the plane 10x plus 15y minus 20z equals to 12 and perpendicular to the plane 3x plus 2y plus 3z equals to 5. Here given equations of plane are 2x plus 3y minus 4z equals to 3, 10x plus 15y minus 20z equals to 12 and 3x plus 2y plus 3z equals to 5. Now we have to show that plane 1 is parallel to plane 2 and plane 1 is perpendicular to plane 3. Now the direction ratios DRS of the normal to the plane 1 and 2 are 2, 3, minus 4 and 10, 15, minus 20 respectively. We have to show that the plane 1 is parallel to the plane 2. अब हामीले प्रुभ गर्नुपर्ने plane 1 plane 2 सँग parallel छ भनेर प्रुभ गर्ने हो. We know that if two planes are parallel to each other, then normals to these planes are also parallel. We know that if two planes are parallel to each other, दुईटा plane parallel छन् भने, then normals to these planes will also be parallel. यो एउटा फर्स्ट प्लेन को नर्मल हो, यो सेकेन्ड प्लेन को नर्मल हो भने फर इक्जाम्पल एउटा सिलिङ माथिको प्लेन छ र हामी बसेको यो उभिएको एउटा फ्लोर अर्को प्लेन छ भने यो सिलिङको नर्मल भयो, यो फ्लोरको नर्मल. In this way, if two planes are parallel to each other, then normals to these planes are also parallel. And if two lines are parallel, then we have the relation A1 by A2 equals to B1 by B2 equals to C1 by C2. We have to show that the plane 1 is parallel to plane 2. We know that if two planes are parallel to each other, then normals to these planes will also be parallel, and hence we have A1 by A2 equals to B1 by B2 equals to C1 by C2, that is 2 upon 10 equals to 3 upon 15 equals to minus 4 upon minus 20. Therefore 1 upon 5 equals to 1 upon 5 equals to 1 upon 5, which shows that the plane 1 is parallel to the plane 2. In this way, we have shown that plane 1 is parallel to plane 2. Again, अब यसै गरी हामीले अब plane 1 plane 3 सँग perpendicular छ भनेर प्रुभ गर्ने हो. If two planes are perpendicular to each other, then the normals to these planes will also be perpendicular. Suppose यो यतापट्टिको wall को normal छ, यो हाम्रो floor को normal छ भने, if two planes are perpendicular to each other, then normals to these planes will also be perpendicular. Again, the direction ratios of the normal to the plane 3 are 3, 2, 5. We have to prove plane 1 is perpendicular to the plane 1 to the plane 3. We know that if two planes are perpendicular, then normals to these planes will also be perpendicular, and hence we have A1 A2 plus B1 B2 plus C1 C2 equals to 0. यदि दुईटा लाइनहरू दुईटा नर्मलहरू एक आपसमा परपेंडिकुलर छन् भने then the sum of the product of the direction ratios of these two lines will be equals to 0. That is, अब A1 A2 भनेको प्लेन 1 का नर्मल का डाइरेक्सन रेशियोलाई सपोज गरौँ अनि A2 B2 C2 भनेको प्लेन 3 का नर्मल का डाइरेक्सन रेशियोलाई सपोज गरौँ. त्यसो गर्दाखेरि अब हाम्रो यहाँ आयो 2 into 3 plus 3 into 2 plus minus 4 into 5 equals to 0. A1 A2 plus B1 B2 plus C1 C2 equals to 0. That is 2 into 3 plus 3 into 2 plus minus 4 into 3 equals to 0. 6 plus 6 minus 12 equals to 0. Therefore 0 equals to 0, which shows that plane 1 is perpendicular to the plane 3. In this way, we have shown that the plane 1 is perpendicular to the plane 3. Now we have the another question. Find the equation of the plane through the point 1, 2, 3 and normal to the planes x minus y minus z equals to 5 and 2x minus 5y minus 3z equals to 7. अब हामीले के देखाउनु पर्यो भने एउटा यस्तो इक्वेसन अफ प्लेन फाइन्ड गर्नु पर्यो जुन 1, 2, 3 बाट पास हुन्छ र त्यो 1, 2, 3 बाट पास हुने प्लेन यो प्लेन र यो प्लेनसँग परपेंडिकुलर अर नर्मल छ भनेर निकाल्नु पर्यो, देखाउनु पर्यो. यसका लागि सल्युसनमा जाउँ. हियर पहिला 1 पोइन्ट भएर जाने प्लेनको इक्वेसन लेखौँ. वी नो दैट हियर equation of the plane passing through the point 1, 2, 3 is a into x minus 1 plus b into x minus 2 plus c into z minus 3 equals to 0. Let it be 1. Now, if the plane 1 is normal, that is a normal भनेको यहाँनिर perpendicular. Now, if the plane 1 is normal or perpendicular to the plane x minus y minus z equals to 5, then we have यदि एउटा प्लेन अर्को प्लेनसँग परपेन्डिकुलर छ भने then normals to these planes will also be perpendicular to each other, and in that case we can use the formula a1 a2 plus b1 b2 plus c1 c2 equals to 0. Here a b c are the direction ratios of the normal to the plane 1. Likewise, the direction ratio of the normal to the plane dish are 1 comma minus 1 comma minus 1. That is, the coefficient of x y z are considered as the direction ratio of the normal to this plane. Then we have a into 1 a1 a2 plus b into minus 1 plus c into minus 1 equals to 0. This is by formula a1 a2 plus b1 b2 plus c1 c2 equals to 0. If two planes are perpendicular to each other, then normals to these planes will also be perpendicular, and hence we have the result a1 a2 plus b1 b2 plus c1 c2 equals to 0. Therefore a minus b minus c equals to 0. Let it be equation 2. Again, if plane 1 is perpendicular, if plane 1 is perpendicular, that is normal to the plane 2x minus 5y minus 3z equals to 7, then we have फेरि अघिकै रिजल्ट युज गरौँ. यदि एउटा प्लेन 1 प्लेन योसँग परपेन्डिकुलर छ भने then the normals to these planes will also be perpendicular, and hence we have a1 a2 a into 2 plus b into minus 5 plus c into minus 3 equals to 0. Here ABC are the direction ratio of the normal to the plane 1, and 2 comma minus 5 comma minus 3, which are the coefficient of x y z in this plane, are the direction ratios of the normal to the plane. So a1 a2 plus b1 b2 plus c1 c2 equals to 0. Therefore 2a minus 5b minus 3c equals to 0. Let it be equation 3. Now solving equations 2 and 3 by cross multiplication rule for a, b and c. अब a, b र c को भ्यालु थाहा भयो भने we can find the required equation of the plane which passes through the point 1, 2, 3. ओके, अब हामीले के लेख्यौं यहाँनिर दुईटै इक्वेसन का a, b, c का कोएफिसिएन्ट लेख्यौं 1, -1, -2, -5, -3. फर्स्ट दुईटालाई रिपिट गर्ने देन सल्भ गर्ने. अब फर्स्टलाई छोडिन्छ, डिफरेन्ट मेथड छन्. त्यो डिफरेन्ट मेथडमा एउटा मेथड यो पनि हो. अनि यो a अपन राख्ने, यो b अपन, यो c अपन. यसो गर्दाखेरि that is a अपन 3 minus 5 equals to b अपन minus 2 plus 3 equals to c अपन minus 5 plus 2. That is a upon minus 2 equals to b upon 1 equals to c upon minus 3 equals to k say. Therefore a upon minus 2 equals to k implies a equals to minus 2k. b upon 1 equals to k implies b equals to k, and c upon minus 3 equals to k implies c equals to minus 3k. Then substituting the values of ABC in equation 1, we get minus 2k into x minus 1 plus k into y minus 2 plus minus 3k into z minus 3 equals to 0. Taking k common, minus 2 into x minus 1 plus y minus 2 minus 3 into z minus 3 equals to 0. or k उता गयो k उता गएपछि 0 by k भयो 0 भयो and here minus 2x plus 2 plus y minus 2 minus 3z plus 9 equals to 0 or minus 2x plus y minus 3z plus 9 equals to 0. Therefore 2x minus y plus 3z minus 9 equals to 0, which is the required equation of the plane passing through the point 1, 2, 3 and perpendicular to the given planes. Find the equation of the plane through the point 2, minus 3, 1 and perpendicular to the line joining the 2 points 3, 4, minus 1 and 2, minus 5, 1. First of all, we have to find the equation of the plane which passes through the point 2, minus 3, 1. Here, equation of the plane through the point 2, minus 3, 1 is a into x minus x1 को ठाउँमा 2 छ plus b into y minus y1 भनेको minus 3 छ y1 को ठाउँमा plus c into z minus 1 equals to 0. Let it be 1. Now this plane is perpendicular to the line joining the 2 points 3, 4, minus 1 and 2, minus 1, 5. अब हामीले suppose that this white paper is a plane and this is the normal of this plane. This marker is the normal of this plane. Now we have to prove that this plane is perpendicular to the line. Suppose this is the normal and this is the another marker is in this way. One is the left one is the normal of the plane and the right one is the line which is perpendicular to this white paper, that is which is perpendicular to the plane. If a line is perpendicular to the plane, then this line which is on the right of which is the right of the marker, the right marker is the line joining two given. Now we have to show that if the plane if the given plane is perpendicular to this line, any one of, we can suppose any one line. If a plane is perpendicular to the line, then it is parallel to the normal of that plane. So if two lines are parallel to each other, then we have a1 by a2 equals to b1 by b2 equals to c1 by c2. Now the direction ratios of the line joining the points 3, 4, minus 1 and 2, minus 1, 5. Now the direction ratio of the line joining the point 3, 4, minus 1 and 2, minus 1, 5 are 2 minus 3, minus 1 minus 4, 5 minus 1, 5 plus 1, that is minus 1, minus 5, 6, which are the direction ratio of the line joining two given points. Again, if the line joining two given points are is perpendicular to the plane 1, then it must be then the line and the normal to the plane must be parallel to each other. And so we have a upon minus 1 equals to b upon minus 5 equals to c upon 6. That is a upon minus 1 equals to b upon minus 5 equals to c upon 6 equals to k c. Here a upon minus 1 equals to k implies a equals to minus k, b upon minus 5 equals to k implies b equals to minus k, 5k, and c upon 6 equals to k implies c equals to 6k. Substituting the values of a, b, c in equation 1, we get minus k into x minus 2 plus minus 5k into y plus 3 plus 6k into z minus 1 equals to 0. Taking k common, minus into x minus 2 plus minus 5 into y plus 3 plus 6 into z minus 1 equals to 0. Dividing both sides by k, we get minus x plus 2 minus 5y minus 15 plus 6z minus 6 equals to 0, or minus x minus 5y plus 6z minus 19 equals to 0. Therefore x plus 5y minus 6z plus 19 equals to 0, which is the required equation of the plane passing through the given point and perpendicular to the line joining the given points. Here we have the another question. Find the equation of the plane through the point 2, 2, 1 and 9, 3, 6 and normal to the plane 2x plus 6y plus 6z equals to 9. अब हामीले के निकाल्नु पर्यो भने यस्तो प्लेनको इक्वेसन निकालौं जुन 2, 2, 1 र 9, 3, 6 बाट पास हुन्छ र त्यो प्लेन यो अर्को प्लेनसँग परपेन्डिकुलर हुन्छ. अब यसका लागि फर्स्ट अफ अल वी हैव टु फाइन्ड द इक्वेसन अफ द प्लेन व्हिच पासेस थ्रु द पोइन्ट 2, 2, 1 हैन. त्यसपछि त्यो प्लेनमा यो पोइन्टलाई स्याटिस्फाई गराइदिउँ, एउटा इक्वेसन आउँछ. अनि त्यो प्लेन 1 यो प्लेनसँग नर्मल हुने कन्डिसन लगाइदिउँ. दुईटा प्लेन नर्मल छन् भने तिनीहरुका नर्मल पनि एक आपसमा परपेन्डिकुलर हुन्छन्. त्यसबाट दुईवटा इक्वेसन निकाल्ने छौं हामीले. त्यो दुईटा इक्वेसनलाई क्रस मल्टिप्लिकेसन रुल लगाएर सल्भ गर्दाखेरि वी विल फाइन्ड द भ्यालुज अफ एबीसी एन्ड फाइनली सब्स्टिट्युटिङ द भ्यालुज अफ एबीसी इन इक्वेसन 1 वी गेट द रिक्वायर्ड इक्वेसन अफ द प्लेन. सो here equation of the plane passing through the point 2, 2, 1 is a into x minus x1 plus b into y minus y1 plus c into z minus 1 equals to 0. Let it be equation 1. If this plane passes through the point 9, 3, 6, then we have a into 9 minus 2 plus b into 3 minus 2 plus c into z 6 minus 1 equals to 0. Therefore, 7a plus 1b plus 5c equals to 0. Let it be equation 2. By question plane 1 is normal, that is perpendicular to the plane two x plus 6y plus 6z equals to 9. So we have show the normals to these planes will also be perpendicular, and hence we have 2a plus 6b plus 6c equals to 0. a1 a2 plus b1 b2 plus c1 c2 equals to 0. Taking 2 common and cancel, we get therefore a plus 3b plus 3c equals to 0. Let it be equation 3. Now solving equation 2 and 3 by cross multiplication rule for ABC, we get 7, 1, 5 are the coefficient of ABC from equation 2, and 1, 3, 3 are the coefficient of ABC from equation 3. Now our first दुईटालाई रिपिट गरौँ 7, 1, 1, 3 मल्टिप्लाई गर्दा फर्स्टकोलाई छोडौँ, यो अपवार्ड मल्टिप्लाई गर्दा नेगेटिभ र डाउनवार्ड मल्टिप्लाई गर्दा पोजिटिभ हुन्छ. द्याट इज अब a upon 3 minus 15 equals to b upon 5 minus 21 equals to c upon 21 minus 1, that is a upon minus 12 equals to b upon minus 16 equals to c upon 20. Therefore, a upon minus 3 equals to b upon minus 4 equals to c upon 5 equals to k. Say from a upon minus 3 equals to k implies a equals to minus 3k, b upon minus 4 equals to k implies b equals to minus 4k, and c upon 5 equals to k implies c equals to 5k. Now substituting the values of a, b, c in equation 1, we get minus 3k into x minus 2 minus 4k into y minus 2 plus 5k into z minus 1 equals to 0. Taking k common, minus 3 into x minus 2 minus 4 into y minus 2 plus 5 into z minus 1 equals to 0. Eliminating k, we get minus 3x plus 6 minus 4y plus 8 plus 5z minus 5 equals to 0, or minus 3x minus 4y plus 5z plus 9 equals to 0. Therefore 3x plus 4y minus 5z minus 9 equals to 0, which is the required equation of the plane. Find the equation of the plane through the intersection of the planes this and perpendicular to the plane this. अब दुईवटा प्लेन को पोइन्ट अफ इन्टरसेक्सनबाट जाने थर्ड प्लेन र त्यो प्लेन अर्को गिभन प्लेनसँग परपेन्डिकुलर छ भनेर प्रुभ गर्नको लागि हामीले यसो गरौँ। एउटा प्लेन यो कागजको यो पाना छ बुकको, एउटा यो छ भने यो दुईटाको इन्टरसेक्सनबाट जाने थर्ड प्लेन भने हाम्रो यो प्लेन हो। यसको इक्वेसन निकाल्नु पर्यो। अब यो प्लेन के छ, अर्को कुनै एउटा प्लेनसँग परपेन्डिकुलर छ, त्यो यता छेउमा पनि हुनसक्छ, माथि पनि हुनसक्छ, अर्को साइडमा पनि हुनसक्छ। त्यसैले वी हेभ टु फाइन्ड द इक्वेसन अफ द प्लेन विच पासेस थ्रु द इन्टरसेक्सन अफ द टु प्लेन। एउटा प्लेन एउटा यो छ, एउटा यो छ, यो दुईटै प्लेनको एउटा यो प्लेन एउटा यो प्लेन, यो दुईटै प्लेनको पोइन्ट अफ इन्टरसेक्सनबाट जाने थर्ड प्लेन यो हो र यो प्लेन अर्को गिभन प्लेनसँग के छ, परपेन्डिकुलर छ। Now we have to find the equation of the plane which passes through the intersection of the two given planes and is perpendicular to this plane. Here, equation of the plane through the intersection of of the planes x plus y plus z equals to 6 and 2x plus 3y plus 4z plus 5 equals to 0 is x plus y plus z minus 6 plus lambda into 2x plus 3y plus 4z plus 5 equals to 0। दुईटा गिभन प्लेनको इन्टरसेक्सनबाट जाने थर्ड प्लेनको इक्वेसन यसो हुन्छ, एउटा प्लेन प्लस सम कन्स्टेन्ट टाइम्स अर्को प्लेन इक्वल्स टु 0 हुन्छ। द प्रुफ अफ दिस फर्मुला इज गिभन इन युर बुक, यु क्यान फाइन्ड देयर एन्ड मेनी अदर रेफरेन्स बुक्स। ओके, लेट इट बी इक्वेसन 1। अब ल्याम्डाको भ्यालु निकाल्नु पर्यो। यसका लागि this equation can also be written as, that is 1 plus 2 lambda into x plus 1 plus 3 lambda into y plus 1 plus 4 lambda into z plus 5 lambda minus 6 equals to 0. This plane is perpendicular to the plane 4x plus 5y minus 3z equals to 8। अब यो प्लेन यो गिभन प्लेनसँग perpendicular छ। That means if two planes are perpendicular to each other, then the normals to these planes will also be perpendicular, and then we have a1 a2 plus b1 b2 plus c1 c2 equals to 0। हामीले यस अगाडिका प्रोब्लममा पनि यो कुरा हामीले गरिसकेका छौं। This plane is perpendicular to this plane, to the plane this, so we have 1 plus 2 lambda into 4 plus 1 plus 3 lambda into 5 plus 1 plus 4 lambda into minus 3 equals to 0. If two planes are perpendicular to each other, then the normals to these planes will also be perpendicular, and hence we have a1 a2 plus b1 b2 plus c1 c2 equals 0। अब यसलाई सिम्प्लिफाई गरेर हामीले ल्याम्डाको भ्यालु निकालौं र त्यो ल्याम्डाको भ्यालुलाई इक्वेसन 1 मा सब्स्टिट्युट गर्दाखेरि we get the required equation of the plane which passes through the point of intersection of the two given plane and perpendicular as well as the perpendicular to the given plane. So or 4 plus 8 lambda plus 5 plus 15 lambda plus 5 plus 15 lambda minus 3 minus 12 lambda equals to 0. On simplification, 15 minus 12, 3, 11 lambda plus 6 equals to 0. Therefore, lambda equals to minus 6 by 11. Now substituting the value of lambda in equation 1, we get x plus y plus z minus 6. अब lambda को ठाउँमा plus lambda थियो, यहाँनिर हामीले 6 by 11 राख्यौं into 2x plus 3y plus 4z plus 5 equals to 0. अब एलसीएम निकालौं और 11x plus 11y plus 11z minus 66 minus 12x minus 18y minus 24z minus 20 equals to 0. अब x भएका टर्म एक ठाउँमा ल्याउँ के आयो minus x 11y र 18 मा minus 7y minus यो र z भएको टर्म ल्याऊ एक ठाउँमा minus 13z minus 86 equals to 0. Therefore, x plus 7y plus 13z plus 86 equals to 0, which is the required equation of the plane. Which is the required equation of the plane. Simplification 11x plus 11y plus 11z minus 66 minus 12x minus 18y minus 24z minus 30 equals to 0. like term add र subtract गरौँ और minus x भयो अनि 11y 18 minus को 18y यो minus 7y अनि 11z positive minus 24z गर्दा minus 13z minus 96 equals to 0 और minus common झिकौं x plus 7y plus 13z plus 96 equals to 0. Therefore, x plus 7y plus 13z plus 96 equals to 0, which is the required equation of the plane. Which is the required equation of the plane. In this way, we can find the equation of the plane which passes through the intersection of the given plane and perpendicular to the another given plane is of the form this. A variable plane is at a constant distance 3p from origin and meets the axis in the points ABC. Prove that the locus of the centroid of the triangle ABC is 1 by x square plus 1 by y square plus 1 by z square equals to 1 by p square. अब क्वेशनले के भनेको छ भने एउटा भेरिएबल प्लेन छ स्पेसमा, यहाँनिर हामीले एबीसी एउटा प्लेन हो भनेर देखायौं जसले तीनटै एक्सिसमा मिट गरेको छ. दिस इज एबीसी इज प्लेन एज वेल एज इट इज अ ट्रायंगल. अब यो एबीसी प्लेन ओरिजिनबाट 3p युनिटको डिस्टेन्समा टाढा छ. 3p युनिट ओरिजिनबाट टाढा हुने गरी स्पेसमा मुभ गरिरहेछ भने त्यसको सेन्ट्रोइडको लोकस, किनकि डाइरेक्सन चेन्ज, यो पोजिसन प्लेनको पोजिसन चेन्ज हुने बित्तिकै यसको सेन्ट्रोइड पनि चेन्ज हुन्छ. त्यसैले त्यो चेन्ज हुने सेन्ट्रोइडको पोइन्ट्सहरूलाई मिट गर्दाखेरि हुन आउने सेन्ट्रोइडलाई मात्र मिट गर्दाखेरि हुन आउने जुन लोकस छ त्यो लोकस भनेको 1 by x square plus 1 by y square plus 1 by z square equals to 1 by p square हुन्छ भनेर हामीले प्रुभ गर्नुपर्छ. यसका लागि we have supposed that ABC be a plane which meets the coordinate axis at the points ABC at distances small a, small b, small c from origin. Then its equation will be of the form x by a plus y by b plus z by c equals to 1 हुन्छ. किनकि एउटा प्लेनले तीनटै एक्सिसलाई भेट्यो भने इक्वेसन अफ द प्लेन इन इन्टरसेप्ट फर्म हामीले लिनुपर्छ. त्यो भनेको x by a plus y by b plus z by c equals to 1 हुन्छ. अब त्यसपछि also given that 3p equals the length of perpendicular drawn from origin to the plane. अब length of perpendicular को formula लगाइदिउँ. Let the variable plane meets the coordinate axis at the points a, b, c at A comma B comma C at the distance is small a, small b, small c from the origin, then its equation will be of the form x by a plus y by b plus z by c equals to 1. Let it be equation 1. एउटा भेरिएबल प्लेनले कोअर्डिनेट एक्सिसलाई at the point A, B, C मा भेटेको छ. At distances at the point A is small a distance away from origin and point B is small b distance from origin and point C is small c distance from origin. So the equation of the plane will be of the form x by a plus y by b plus z by c equals to 1. By question 3p equals to length of perpendicular from origin to the plane x by a plus y by b plus z by c minus 1 equals to 0, or 3p equals to modulus of length of perpendicular को फर्मुला लगाइदियो. एज इन द केस अफ लाइन प्लेनमा पनि त्यही हुन्छ, एउटा z मात्रै थपिने हो. 1 by a into 0 plus 1 by b into 0 plus 1 by c into 0 minus 1 upon यो ax1 plus by1 plus cz1 minus 1 upon root over a square plus b square plus c square, that is 1 by a square plus 1 by b square plus 1 by c square मोडुलस हुन्छ, और प्लस माइनस पनि लिन मिल्छ. और 3p equals to 1 upon root over 1 by a square plus 1 by b square plus 1 by c square taking reciprocal on both sides. We get 1 upon 3p equals to root over 1 by a square plus 1 by b square plus 1 by c square को root भयो. Squaring on both sides, we get 1 upon 9p square equals to 1 by a square plus 1 by b square plus 1 by c square. Let it be equation 2. Suppose that alpha, beta, gamma be the centroid of the triangle ABC. Then we have अब हामीले सेन्ट्रोइडको लोकस 1 by x square plus 1 by y square plus 1 by z square equals to 1 by p square हुन्छ भनेर हामीले प्रुभ गर्नुपर्छ. त्यसका लागि मानौ त्यो भेरिएबल प्लेनको भेरिएबल जुन ट्रायंगल छ इन स्पेसमा त्यसको सेन्ट्रोइड अल्फा बीटा गामा हो भन्थ्यो. यसबाट रिलेसन ल्याउ. देन वी हैव अल्फा इक्वल्स टु a plus 0 plus 0 by 3. This implies a equals to 3 alpha. Beta equals to 0 plus b plus 0 by 3 implies b equals to 3 beta, and gamma equals to 0 plus 0 plus c upon 3 implies c equals to 3 gamma. You x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, and z1 plus z2 plus z3 by 3. This is the formula for finding the centroid of the triangle ABC. From 2, now from equation 2 we have 1 upon 9p square equals to 1 upon 9 alpha square plus 1 upon 9 beta square plus 1 upon 9 gamma square. That is there. That is 1 upon 9 common झिक्यो 1 by alpha square plus 1 by beta square plus 1 by gamma square equals to 1 upon 9p square, cancelling 9 from both sides. That is 1 upon alpha square plus 1 upon beta square plus 1 upon gamma square equals to 1 upon p square. Hence the required locus of the centroid of the triangle ABC is 1 upon x square plus 1 upon y square plus 1 upon z square equals to 1 upon p square. This completes your proof.